Okay, moving on to our next lesson, 1.5, the sine law. We are going to be answering questions now that do not involve right angle triangles. Okay, so the right angle triangles we know can be solved using the primary trig ratios, right? And so, quick recap, what are your primary trig ratios? That's your SOHCAHTOA, right? That's your sine theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. Well, we know that not all situations in real life applications involve right angle triangles. So there is another formula we can use to help us with that. Now, the derivation of the formula you can find on my website. I posted a link there that shows the derivation and where it comes from. All right, so I'm not going to bother right now discussing the derivation. If you want to look into that and where it comes from, you can see that on my site. But let's continue with our sine law. All right, so the sine law states that the ratio of one of your sides to its opposite angle, the sine of its opposite angle, that ratio is equal to another side in your triangle compared to the sine of its angle, which is also equal to the proportion of the other side to its angle, to the sine of its angle as well. So here's your sine law, and we only ever use two of these ratios to solve a problem based on what we're given in the question. We can use any two of these. So you're never going to need to use all three here. Okay, so what you're going to do is you're going to, based on what's given in your triangle, just use two of these ratios, and you should have three of the values. Like you should, for example, perhaps a question gives you the side length of A, the side length of B, angle A, and you have to find angle B. We would simply cross multiply to solve for angle B. All right. Now, there's two versions of this formula, but they're the exact same. Because you're dealing with proportions, it doesn't matter whether you write your formula with the sine of the angle in the numerator or whether you write it in the denominator. Okay, so don't be confused by that. It's the exact same thing. You're just setting up a proportion, essentially. And so as long as you line up, let's say, your angles along the numerator and your side lengths along the denominator, you can interchange that. You can line up your side lengths in the numerator, angles in the denominator. Now, it just so happens that if you're solving for a side length, it's ideal to use this formula here. All right, you just have one less step in your algebra and you're solving if you're solving for a side length. If you're solving for an angle, it is more ideal to use this formula, this version of it, only because there's just one less step in the way you solve for the unknown. All right, but let's look at a triangle and let's label it, and then we'll see how to associate the formula with what the triangle is labeled with. So let's say we have a triangle. Let's call it ABC, capital A, capital B, capital C. Angles always use capital letters, side lengths use lowercase. And you don't have to use ABC. You can use any three letters you want and change these letters in your formula accordingly. Okay, so the way you label these triangles, you're not labeling it with opposite, hypotenuse, and adjacent anymore. Right? What you're doing is, if this is angle A, then side length A is opposite, and it's a lowercase a. Okay? Across from angle B, you'll have lowercase b. And across from angle C, you'll have lowercase c. And it doesn't matter, again, what letters you use as long as they correspond with each other. So you can label it DEF. Just make sure you use the lowercase letters of DEF. Okay, so the question becomes, when do we use the sine law? Well, we know that if you don't have a right angle triangle, there's potential to use the sine law. Depends on what is given to you. Because as you know, we're going to learn another formula or go back over another formula in the next lesson called the cosine law. All right, so the sine law can be used if you're given, okay, an angle and opposite side length, okay, plus another angle in the triangle. Okay, so if you have an angle and an opposite side, so let's say you have angle A and you have an opposite side length given, plus you have another angle somewhere given, you can use the sine law. Okay, also, if you have, again, an angle and opposite side length, except instead of having another angle, you instead have another side length. Okay, you can also use the sine law. So for example, if you are given angle A, side length A, and you're given side length C, you can then solve for angle C. All right, so those are the two situations. You're basically looking for opposites, right? You're looking for an opposite pair, like an angle and an opposite side, and then something else from the triangle, either a side length or an angle. And if you have that situation, you can use the sine law. Okay? So let's dive into a problem. Now, I know this should be review for you. There should be nothing new here, as you would have all done this in grade 11, but I'm going to go a little bit faster just to kind of refresh your memory here, but here we go. So we have a triangle. It's clearly not a right angle triangle. Okay, we can't assume that that is a 90-degree angle there. There's no indication. There's no little box indicating the right angle there. It says find the unknown values of each triangle. So we have to find, in this case, lowercase d, or side length d. So first, let's get in the habit of checking if we can use the sine law. We are given an angle and an opposite side, and then we're given another angle, which is great. That means we can use the sine law. Again, you're looking for this opposite angle side length situation, okay? So we have it here, so that's good. We are gonna find lowercase d, all right? And let's start by labeling the triangle. If this is capital F, then this must be lowercase f, and this must be lowercase e. Okay, so let's write out our formula. Now we're solving for a side length, so let's use this version of the formula. So I had mentioned that up above. Use the version where the side lengths are in the numerator. It'll just be a little bit easier for us. So d over sine of capital D is equal to E over sine capital E, which is equal to F over sine capital F. But you're probably looking at this and saying, we only need two of these ratios to solve, and we have no information for E, right? We've got no information for E, so we don't need it. So all we're going to be left with is D over sine capital D is equal to F over sine capital F. Let's substitute all our values in. Leave D as it is because we need to solve for D. Put in your angle D, which is 50. Put in your lowercase f, which is 54. And your angle F, which is 34. All right, now straightforward here, we're just going to cross multiply. So we get D times sine 34 is equal to 54 times sine 50, right? We need to solve for D. So what are we going to do to get D by itself? We are going to divide on the other side by sine 34. So D is equal to 54 times sine 50 divided by 34, and you get 74 centimeters. Okay, so we solve for the unknown there. Fairly straightforward, right? So here we go again. We are looking for an opposite situation once again, right? And we have it. We are given an angle in its opposite side, and then we're given an extra side length, which means that we can find angle B. Okay, so let's set it up. This is an ABC triangle. So we're finding the angle. So let's put the angles in the numerator. Okay. You can probably see now, by the way, let's label our triangle. This is lowercase a, this is lowercase b. You can probably see that there's nothing given for C here. So we're not going to use that ratio. Let's sub in all our values. Sine of 39 degrees divided by lowercase a, which is 8, is equal to sine of angle B, which we don't know, we need to solve for, divided by 12. Let's cross multiply. You get 12 times sine 39 is equal to 8 times sine B. Now, we need to isolate for B to solve for it. So the first number we're going to move over is our 8. We're going to divide 8 on both sides. You're going to get 12 times sine 39 divided by 8 equals sine B. Okay. Let's work this out on our calculator, and I would definitely try to keep at least 4 decimal places here as you're working out throughout your solution. So you end up getting 0.9439 is equal to sine of B. And now we should know how to isolate B here. We're going to do the inverse sine to bring it over to the other side. So you're going to get sine inverse 0.9439 equals capital B. Final answer is 71 degrees to the nearest degree. Okay, fairly straightforward there, right? Let's move on to, we've got 2 word problems that we're going to work on. Now, I should mention that there's going to be 2 parts to this lesson. The second part, we're going to be looking at special cases of the sine law where we need to do a couple extra calculations. So it's called the ambiguous case of the sine law. For these 2 word problems, that's not an issue. All right, so we're just going to dive right in. And you always want to have a strategy when you're solving these. Your step 1 is always to draw diagrams. You have to draw your diagram. And you usually draw separate diagrams. It's usually 2 or 3 that you end up drawing. So you end up drawing like one big diagram of what's happening here. And then just so that things don't stay too sloppy, you pull the triangles out of your diagram and label them kind of separately outside of your primary diagram. So let's look at that. So let's see, a telephone pole is supported by an 18-meter guy wire that makes an angle of 50 degrees with the horizontal ground. So we've got a telephone pole, okay, is supported by an 18-meter guy wire that makes an angle of 50 degrees with the horizontal. A 14-meter guy wire is to be fastened on the other side of the pole for reinforcement. Both wires attach to the pole at its top, okay? So that's what I was waiting to see because I didn't know where to attach this, whether it was kind of in the middle or if it was at the top. So the question told me it is at the top, okay? So I have 2 separate guy wires holding this pole straight, and they're fastened to the ground down here. So there's tension in that wire. One of the wires is 18 meters. It doesn't matter which one. The other wire is 14 meters. The 18-meter guy wire makes an angle of 50 degrees with the horizontal ground. Okay, so 50 degrees with the ground. Okay, what angle should the second wire make with the ground? So we are looking for this here. Label your triangle. Now you can use any letters you want. I'm going to use ABC. Okay, and you can see that we have a non-right angle triangle. Although we have two right angle triangles, let's solve this as just one big triangle here. All right, so from this point here, I would say your first step should be to label or maybe even redraw the diagram without having this obstruction here. That's probably where I would go with this, just to have a nice, neater diagram where this is 18. We've got your 50-degree angle. We've got your unknown. We've got your 14 meter here, and let's label it as A, B, C. All right, and this is lowercase a, this would be lowercase c, and lowercase b. So you can see we can use the sine law here because we do have one of these opposite situations given. And then we have an additional side length here as well, which means we can find angle C, which is what we're looking for. They're saying what angle should the second wire make with the ground? This is your second wire here. So we are looking for angle C. Because you're looking for an angle, put your angles in the numerator. And notice how I'm always writing out all three ratios. Now, I wouldn't normally do that, but I'm just trying to make it as clear as possible what I'm doing here, because clearly there's nothing given for angle B, so we're not going to use that proportion. Okay, so let's fill in our values. Okay, and then cross multiply and solve for angle C. So we're going to get 18 times the sine of 50 is equal to 14 times the sine of angle C. Divide both sides by 14. You end up getting 18 times the sine of 50 divided by 14 is equal to sine of angle C. Okay, and you end up getting to 4 decimal places on the left here, 0.9849. Take the inverse sine. Okay, so move sine over, take the inverse of 0.9849, and you end up getting rounded to the nearest degree, because I believe they told us to round to the nearest degree, right? We get 80 degrees equals angle C. Okay, so this wire here can be made at an angle of 50, and that makes sense. So it's a lower angle, which will provide a lower side length, right? Whereas the larger angle here of 80 will yield a larger side length on the opposite side of 18. So always check the reasonableness of your answer, right? Always get in the habit of doing that. Next example. 2 helicopters flying at the same altitude spot a boat in distress on the water below and between them. The helicopters are 1.2 kilometers apart. So we've got a helicopter here and a helicopter here. Let's assume they're at the same height, okay? They are 1.2 kilometers apart. They spot a boat in distress on the water below. So if the water's down here, there's a boat, it's between them, somewhere between them here. Okay, it doesn't matter where, it's between them. The angles of depression to the boat are 53 and 42 degrees respectively. So that means from this one here, it's the angle of depression. So it's with the horizontal. This is 53. And over here, this would be 42. At the end of the day, it doesn't matter where you put which one. Okay. The Coast Guard is trying to decide which helicopter to respond to the distress call, should respond to the distress call. How far is each helicopter from the boat? Which one then should respond? Okay, so we are essentially looking for this side length and this side length to figure out how far away they each are from the boat. Okay, I'm going to redraw this diagram, so don't worry about that. So I'm looking at this and I'm saying, hey, I don't have a sine law situation. I don't have an angle and an opposite side length given, right? I don't have both given. I have one, I have a side length, but I don't have an angle. And here I have an angle but no side length, and here I have an angle but no side length. So how can we use sine law here? Well, what we need to remember is that the sum of the angles in a triangle is equal to how many degrees? 180 degrees. So if we know two of the angles, 53 and 42, we can find the third angle because we know that all three should add up to 180, right? So let's redraw this a little bit nicer without the water. Okay, so here we have our 53. Here we have our 42. Here we have our 1.2. Let's label it A, B, C. If this is angle A, then this must be lowercase a, this must be lowercase b, this must be lowercase c. Let's find angle A because we can. So let's do 180, subtract 53, subtract another 42, and whatever's left over, you'll end up getting what angle A is. So it's 85 degrees. Okay, so here we have an 85 degrees. Now we have a sine law situation because we are given an angle and an opposite side. We can now find lowercase b and we can find lowercase c in two separate calculations, right? Two separate calculations. So we've got, since we're finding side lengths, let's put the side lengths in the numerator, and let's find side length b first. So okay, so this is for side length b. Okay, we can cross off c. We're not going to be using, even though we do know an angle there, it's irrelevant to us because we're only solving for b right now, and we need to include a because we're actually given everything for a. We're given the side length and we're given the angle for a, right? So that must be included. Okay, cross multiply. Okay, divide out the sine 85 onto the left. Okay, and work this out on your calculator. And you're probably wondering, can you just calculate sine 53 and sine 85 and write them in? I would keep them as is because if you start rounding too much within your answer, your final answer will be just a little bit more inaccurate. So actually type in 1.2 times sine 53, then take that and divide it by sine of 85. Okay, and you end up getting So you end up getting 0.9620 is equal to the, is equal to B. All right, so that's 4 decimal places, but let's make sense of this answer. So we're at about 0.9620 kilometers, right? Make sure you put in your units here at this point so you know what you found, right? You didn't just find, and that number makes sense, right? Because if we're dealing with a 1.2 here, getting a number that's fairly close to that, like 0.9620, makes total sense. Let's now find lowercase c. So once again, we want to use the ratios that include a because we're given everything for a, right? So what I'm going to do is actually cancel out my ratio for b this time. And Let's fill in all our values. And cross multiply. Okay, divide both sides by sine 85. And again, notice I'm not punching in sine 85 into my calculator or sine 42 just yet, because I want to keep as much accuracy as possible right now. So in my calculator, I do 1.2 times the sine of 42 divided by the sine of 85. And here you get 0.8060 kilometers is equal to c, lowercase c that is. So we have 0.8060 here, and we have 0.9620 here. Which helicopter is closer? Okay, clearly the helicopter that makes an angle of 42 degrees is closer. Okay, so we can say that therefore helicopter, and we called it C, that point, so let's call it helicopter C, is closer. All right, that does it for these word problems. Like I said, you're going to need to draw diagrams for all of these word problems to help you visualize what's happening, or you simply really just can't. Okay,